We're doing some more work today with conic sections. This time, additional work with the circle. That's that section you get when you cut a cone perpendicular to its axis. Uh, Today, we're being asked to write an equation for a circle in standard form uh, when we're given the center and a point that it passes through. This is the equation of a circle in standard form where hk are the coordinates of your center of the circle, and then here is the radius squared out here. So what we need to do first of all is know the center of our circle, and we could fill those numbers in right here. That's pretty easy. They're giving us the center. X minus a negative 2 would be x plus 2 squared. And then y minus 0 squared, we can just write as y squared. So that's all there is to the left-hand side of the equation. That's not tough at all. How about this number, the radius of the circle? How can we find that? Well, we're also told that the circle passes through this point, 6, 4. So the radius is going to be the distance of this center to this point. So we can use the distance formula for that. And remember, the distance formula says the distance is the square root of the difference of the x-coordinates squared plus the difference of the y-coordinates squared. So let's see, the x-coordinates are 8 units apart, so that's 8 squared. The y-coordinates are 4 units apart, so that's 4 squared. So, and I'm going to replace distance with radius because that's what we're finding. So the radius is the square root of 64 plus 16. So the radius is the square root of 80. And actually, we're not looking for the radius. We're looking for the radius squared. That's the number that goes out here. And that's convenient because then we don't have to bother with this silly square root. We can just square this thing, and we get the radius squared equals 80. So to finish our equation, we just put 80 out here, and that is done. We have written an equation for this circle in standard form.